Alright, so here we are with the 3-5 assignment. We're going with part 2 here because I ran out of time. So, number 49 is what we're going with. 49, as I started to mention in the previous video, starts with the Newton's law of cooling formula, so we are going to need to have that. So as you access your formula sheet, they're saying that the temperature comes from the temperature of the surrounding medium. To that we will add the temperature initially of whatever the object was, in this case a cup of coffee, and then we'll subtract again that temperature of the surrounding medium, and to that we will multiply e to the negative k from this specific problem, times t for time. So, taking a look at what they give you, notice that the cup of coffee has cooled from 92 degrees Celsius, which would have been the initial temperature, to 50 degrees Celsius, which would be the temperature after a certain amount of minutes. So that would have been T. They're also telling you that your surrounding medium is going to be 22 degrees Celsius, so that should be T sub m. And so first we need to find our k value. Once we find our k value, we can then answer this question of how long it will take to cool to 30 degrees Celsius. So let's go ahead and fill in what they give you. So again, T of T is going to be 50 from what they give you. T sub m, the temperature of the surrounding medium, is going to be 22. To that we're going to add the initial temperature, which is 92, and then subtract the temperature around the object, which is 22, multiply by e to the negative k, which we don't know, but we do know how long it'll take, which is 12 minutes. Alright, so then we get to do a little or a lot here, algebra, and so I'm going to get a different color. Alright, I'm going to subtract 22 from both sides. As we look at the order of operations, addition and subtraction is the last, and so when we solve, it's the first. So, subtracting 22. Once we subtract 22 from 50, we get 28, and that's going to be equal to 92 minus 22, which is 70, e to the negative k times 12. That's being multiplied, so we'll go ahead and divide both sides by 70, so 28 over 70 gets you a decimal of 0.4. So 0.4 is going to equal e to the negative 12k if we write it in the way that makes a little bit more sense for solving. And then from here, lots of ways to do this, but notice it's written in exponential format. So how about we just take the time to write it in logarithmic. So if we write it as natural log of base e of 0.4, that's going to equal negative 12k, and so whatever our decimal is, we'll divide by negative 12, and that will be our k. So k is the natural log of 0.4 divided by negative 12. So our k value is 0.7636. Oh, I forgot a 0. 0.0764, since I don't need that many decimals. Alright, so now we get to do the next part. So the next part says, okay, well, instead of a T of T, we're actually going to be determining when it's going to be 30 degrees Celsius. So what time will that be? So 30 is going to equal our T sub m, which we already said was 22. To that we're going to add the 70 again, so I don't necessarily need to rewrite that. So 70 e to the negative our k value, so 0.0764, and then times t, so our one variable that we're trying to solve for. Alright, so same process as before. Let's go ahead and solve by subtracting 22, only now it's from 30 instead of 50. So we'll get 8, and 8 is going to equal 70e to the negative 0.0764t. So we'll divide by 70. 8 divided by 70 leaves you with 0.1143. So it's e to the negative 0.0764t. Yikes. Then it's in exponential format, so if we go ahead and write it in natural log format, we're going to have natural log, well, base e, of 0.1143, and that's going to equal negative 0.07t. I'm just going to abbreviate that because I ran out of room. So in order to solve, we'll divide by that negative 0.07 to as many decimals as we can of that natural log. So natural log of 0.1143, that divided by our k value of negative 0.0764. Alright, so apparently we have 28.39 equal to our t, and so if we look at what they're giving us in this beginning, they're saying minutes, and so that means that it's going to take 28 minutes for that cup of coffee to go from 92 degrees Celsius to 30 degrees Celsius. Super. Very informational. Alright. So next one is the same process. A cake is removed from an oven at 350 degrees. So the oven is at 350, which I assume then the cake is. I'm just not going to assume that. Anyway. Yeah. Okay, so we're going to assume the cake got to 350 degrees, but as you know, that might not actually be how it is. Either way. So that's T sub 0, the initial temperature. It's going to cool to 120 degrees, so that's the temperature it's cooled to, so T of T, after a certain amount of time, so that's T, and then the surrounding medium is 65 degrees. So taking into account our awesome formula, that's an ugly K, we're going to plug in what we've got. So T of T is 120, what we're getting down to in temperature. T sub m, the surrounding medium, is 65. And to that we're going to add the T sub 0, which is 350, minus the T sub m, which is 65. And then e to the negative k, which we don't know, but we do know that t is 20. So if we go ahead and try to solve that, we're going to subtract negative 65, or sorry, subtract 65. And from 65 we're going to get 55. And then that's going to equal 350 minus 65. So 285. And that's going to still be multiplied by e to the negative 20k. I like to write my numbers first before my variables. Alright, then that multiplier is going to have to divide to both sides. So 55 over 285 leaves you with 0.192, 30, because 29 would round to 30. And it's equal to e to the, e to the negative 20k. My hand was resting on the pad there. Okay. So we'll rewrite with natural log. So natural log of 0.1930 is going to equal our exponent. And ultimately we'll want to divide that exponent so that we can finally figure out what k is. And so k is the natural log of 0.1930 divided by negative 20. So positive 0.0823. So now that we know our k value, we can go ahead and plug that into our original equation. And notice that we are trying to find when it cools to 90 degrees Fahrenheit. So now we're actually going to have a different T of T. It's going to be 90. So we've got 90, and 90 is going to equal the temperature of our surround, which was 65, plus that new value that we had, which was 285, times e to the negative k, which we now know is 0.0823, and then times the t that we're trying to find. So we'll subtract our 65. So taking away a 65 gets you 25. We'll divide that 285 to both sides. And so we have 0.0877 e still to the negative 0.0823 times t. Rewriting with natural log, since we have a base of e, leaves you with negative 0.0823t. And so we'll divide by that value of k. And we've got natural log of 0.0877. Yep. Divided by negative 0.0823. Alright, so our t ends up being 29.57, but of course we're talking about minutes, so we may as well round up. So it's about 30 minutes is how long it'll take. So, moving on to our last problem of Newton's law. A thermometer is removed from a cup of coffee and placed in water with a temperature of 10 degrees Celsius. So notice they're even telling us that's Tm. The data in the table was collected over the next 30 seconds. Oh, good to know. Okay. So we need to draw a scatter plot of the data. Really? No thanks. Mostly no thanks, because I'm just not going to take the time to exactly plot out each of this. But if we do graph what's happening, we can, I'll show you kind of what happens. So if we take a look at the data, which literally these are the same, only we've subtracted that 10 from it. So, I mean, I don't know why graphing both of them is really going to help. But it actually, now that I'm looking at it, it does say to just graph this one. So we will just graph this one then. So if we graph that one, you end up kind of starting at about 70. And then as you go down towards about 10, it ends up making this kind of exponential path. Okay, so clearly that would mean that what we're looking at with logarithms and exponentials are going to end up working well. So they want you to find an exponential regression equation for it. So, and then superimpose its graph on top of the scatter plot. So I assume you can see how closely it relates. So, in order to do that, we're going to go to Stat. So we press our Stat button. From there, we're going to go to Edit, which is number 1. And then we're going to plug in our list 1, which is going to be time, and then our list 2, which is going to be the t minus t sub m. And so once you put in all of your data, then in order to get the equation, we're going to press Stat again. And now from Stat, we're going to go over to Calc. Whoops. That's apparently going to spell Calc. And then once you press Enter, let me see. Sorry, I pressed the wrong thing. Then you're going to go down. We don't have to press Enter. And you're going to go to Exponential. So EXPREG, which is apparently number 0. Okay. So once you go to EXPREG, you press Enter. And then most likely on yours, you're going to enter like 4 times. Either way, you're just getting to the home screen where it finally gives you an equation. So in part B, the equation is a times b to the x, and then they tell you that a is 79.4661, and then you're going to multiply that times b, which is 0.9322, and then of course raised to the x. So that's our exponential equation that follows this data. And then part C wants you to estimate the thermometer reading when it is removed from the coffee. And so as you can see, it says that the thermometer is removed from a cup of coffee, and I assume that thermometer is then put into the water for 30 seconds, and then after that taken out. So I guess we're looking at what the prediction of the equation is for a time of 30 seconds. So, time is going to be up here in the exponent, which means that our temperature is going to equal 79.4661 times 0.9322 to the 30. So, bringing that decimal 0.9322 to the 30, and then multiplying that by 79.4661 leaves us with a temperature of 9.6706 degrees. And of course this is in Celsius, so that totally doesn't make sense. So if you kind of do a little Google search, that kind of means that it's about 49.4 degrees Fahrenheit, which makes a whole lot of more sense, I guess, as long as the room is extremely cold. Okay. So, either way, the temperature is going to be 9.6706 degrees Celsius, according to plugging in a 30 seconds and put into the water. And now that I'm reading it again, man, I'm seeing that they actually want T to be 0, because that's when they remove it from the coffee and put it in the water. Too many liquids. Sorry. So, 79.4661 times 0.9322 to the 0 makes that a 1. And so officially the temperature, as it's being removed from the coffee, is 79.466 degrees Celsius. Okay, that is what they were asking. Sweet.